Yo, 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 yo. Last video about scatter plots. We're going to talk about trend lines and making predictions with trend lines. So first, we need to know what a trend line is. A trend line is a straight line to make a prediction from a scatter plot. So if I have a scatter plot, and I'll just show a quick example of what a trend line would look like. So here's a graph, our coordinate plane, and let's say I have my scatter plot. Here are the points of the scatter plot. Okay, so there's my scatter plot points. The scatter plot is in a positive association, it's going up. So what we do is I would want to draw a trend line to show the direction of this data, to show, well, what way is the data moving? Now, when I do a line, we're going to use a straight line like we've always graphed lines. But this straight line is going to try to go in the direction of the data and cover the most data it possibly can. So like if I put this line here, all the data is below it, so it doesn't really show the direction of the data. If I put the trend line here, all the data is above it, so I want it to go kind of through the middle as best as I possibly can. So that line right there shows the direction the data is moving. Now, not all, I don't have any data actually on the line, and that's okay. I'm not trying to hit these points. But what I'm doing is I'm drawing a line that shows the direction the data is moving, and then I use that line to represent the data and that line to make predictions on future other data points, to make predictions about other data points. So this is called a trend line of a scatter plot. So here I have a scatter plot and here I have a trend line already drawn for me. Okay. This shows the relationship between the number of chapters and the total number of pages for several books. So the more chapters, typically speaking, the more pages. What we're going to have to do is we're going to have to write the equation of the trend line. So what we need to do when we write equations of trend lines is we always have to find perfect points. I still have to write my equation as y equals mx plus b. B represents the y-intercept and m represents the slope. So I need to find the slope and I need to find the y-intercept. So the y-intercept for this trend line, luckily, is 0, which makes it pretty easy because with 0 chapters, there's going to be 0 pages, right? So the y-intercept for this one is 0, so that's already done. Now I have to find the slope. So I'm going to use that y-intercept, but what I want to do is I want to look at this graph, and I'm not looking for a perfect point of data, but instead, I'm just looking for a perfect point on the line, not necessarily a perfect point of data. So like if we see like this is a data point that's on the line, however, that's not a perfect point. I don't know what values for x and y that is. So that point doesn't help me. I'm looking for a perfect point that is like at an intersection. Like this right here, this looks like a perfect point to me. And it looks like it's kind of going up 1 over 1 every single time if we look. So I'm looking at the intersections of the line. Once I have my trend line, the data points, they don't really matter anymore. So once I have a trend line, I'm not looking at any of these points on that in the scatter plot. I'm looking at the line only. Well, this line is going up 20 over 2 each time, up 20 over 2, because my rise is going up 20, because that's what the graph is counting by, and then my run is 2. So slope is 20 over 2, which is equal to 10 over 1. So that means 10 pages per chapter. So if there's 2 chapters, we're assuming there's going to be about 20 pages. So 10 pages per single chapter. So that would be the slope of this line. So my trend line is y equals 10x, and this is 10 pages per chapter. Okay. So now I could say, well, hey, let's use this equation. If a book has 26 chapters, how many pages do we think it's going to have? I can plug in 26. That's 10 times 26. And that's going to give me 260. So my prediction is that's going to have about 260 pages. Now, of course, that doesn't have to be exact, but that's a prediction I'm going to make. That should be relatively close. So here's what I want you guys to do. Try to write the equation of this trend line for number of rainy days and number of umbrellas. So number of rainy days and umbrellas. Try to write the trend line for this one right here. write the equation of the trend line. So again, so we're at 0. So that's nice, y-intercept 0. And then now I gotta find my slope, so I gotta find another perfect point here. Well, this one, again, it's not quite going up 1 over 1. It's definitely, it's pretty close though, huh? It's pretty close, but not quite. So it's pretty hard to find a perfect point on this one. So I'm gonna go with, it's just below it. It looks to me like this is a good perfect point, and this would be, the rise would be like right at the end here at 10, 11. So the rise is 10, the run is 11, so it'd be 10 over 11x. Now, if you had y equals just like 1x, I think that is a fine example. Sometimes with our trend lines, we might have different answers, because sometimes it's hard to find these perfect points, right? It's sometimes difficult. So it might not work. Some people might have thought this was the perfect point. That would have given you 9 over 10. So you could have even had 9 over 10x. All of these are really, really close with each other though, right? We're within 1/10 or 1/11 of each other. So with these, because sometimes there won't be a perfect point, and I don't really see any perfect points here. Then there's not a perfect point, we're just gonna get as close as we can, and there's a wide variety of answers that we can have here. And that's okay, but that's fine. So without the perfect points, I'm gonna say 10 over 11x. You might have had y equals 1x. I think that'd be great. I think y equals 9/10 x would also be great. So it's gotta be somewhere close to 1 though. And that's it for those. Now, we're gonna have a few problems here. So Angela recorded the price of different weights of several bulk grains. She made a scatter plot of her data. So we have the weights and different prices of these grains. So first we want to draw a trend line. This is where when we draw our own trend lines, everyone's trend line is going to be a little bit different. Okay? It's going to be a little bit different. So, which is okay, like there's nothing wrong with that, but you might have, your trend line might be at a different y-intercept by just a little bit than somebody else's, and that's fine. So I'm going to draw a trend line right now, and I want you guys to draw a trend line as well. Okay? So it does make sense for it to start at 0, 0, just because if we start at 0, 0, because 0 weight, you're not going to pay any money, right? So that, in the context of the problem, it does make sense to be at 0, 0. So there's my trend line. Yours might be pretty close, maybe a little bit different. What I did make sure, though, to make my life a little bit easier, when you draw one, it's nice to make sure it goes through a perfect point. And I have one right there. I made sure I ended on a perfect point. Because now I have a rise, I have a run, and I can easily figure out my rise is to here and then over to here. Okay? And it looks like it's going to be 180, $1.80, and then 20 ounces. Okay, and then I can simplify that and figure out the cost per ounce. Okay, so this is my trend line, and again, it's a lot easier if we just pick a perfect point, and then when we pick that perfect point, when we do our trend line and we have a perfect point, then we can go from there. Okay, so how do you know whether your trend line is a good fit for the data? The way we know our trend line is a good fit for the data is because it goes with the direction of the data. Like the duration, it's a positive correlation. My trend line is a positive slope. I have the same, almost an equal amount of points above the trend line as I do below the trend line. Like we look, there's 1, 2, 3, 4 above. There's 1, 2, 3, 4, 5 below. So it's a good representation of the data. Okay, so I would write something along the lines of that right here. Write an equation for your trend line. So if I were to write an equation for my trend line, now that's where I got to do that. So I know my y-intercept is 0, and then I have my perfect point. The rise is $1.80. The run is 20 ounces. So I know that's going to be, let's see here. I'm going to divide these both by 10. and that's going to give me the 18 cents for every 2 ounces. I'm going to simplify this. So my slope is really 9 cents per ounce. So my rate of change is 0.09 x, and I can just do that by doing 180 divided by 20. If I did 180 divided by 20 and actually did this division, I would have gotten 0.09. That tells me it's 9 cents per ounce. So the average cost is rate of change is going up 9 cents per ounce. Okay, now I can use this trend line to interpret the price of 7 ounces and extrapolate the price to 50 ounces. So if I have my trend line at 7 ounces is about right here. Okay, so I can either find that point and extrapolate to 50, or what I could also do is I can now just plug in 50 into my equation. So my equation is y equals 9 cents per ounce. So that's y equals 0.09 times 50. And then I can just do that multiplication. Okay, and it's going to be $4.50. So I think 50 ounces based on my equation should cost $4.50 because now I'm plugging that value in for x, the number of ounces, 50. Okay. If I wanted to use my equation of my trend line to interpret the price of 7, again, I can look at my trend line and figure out where it is at 7. It looks like it's right here, which is at 60 cents. Or I could do 9 times 7, which is 63 cents. So for 7 ounces, I could have said 60 cents or 63 cents. That's it, guys. That's all. So the y-intercept's not always going to be 0, so be aware of that. It'll definitely sometimes, like this one right here, it's not going to be 0. So our things to remember is the y-intercept and the m is the slope. Okay, guys, write a trend line in the equation for this particular scatter plot. And if you have any questions, let me know. Good to see us out.